And you should always keep this in mind. Always double check your answers with Wolfram Alpha. Okay? No, let Wolfram Alpha do the whole thing. This is what you should take away from this video. Never calculate something on your own. Always use Wolfram Alpha and let it do the mathematics. A huge thanks to my Patreon supporters for making this episode possible. Welcome back to another video. Two little PSAs at the very start before we dive into the video, and it has to do with woodworking, hence the PSAs. So over on Flammy's Wood I posted my very first bigger woodworking project, part 1 of it. Please go over there and watch it. It would mean a lot to me, even though you're not into woodworking or the like. Just go over there and watch the whole video and tell me what you thought of the editing and the video style in general and what I can do better. Please leave some comments down there below for feedback. It would really mean a lot to me, and it would also support the channel if you gave it a like, comment and subscribe to the channel, etc. Just the watch time is already enough support. So go over there, watch it, link in the description up here too and in the pinned comment. Thank you very much. Other than that, on STEMmerge EU, new wood types are available for the incredibly rigorous headphone stands. Also the old ones in mahogany are available yet again. So yeah, you can check those out too, link in the description. So as I said at the very start of the video, this video has also to do with woodworking, even though it doesn't look like it right now. And it has to do with something that we derived a few days ago, namely the harmonic addition theorem. Link down there in the description. If you don't know what this is about, what you can do is you can express each and every addition of sinusoidal and cosine waves basically as some kind of, I call it eta, times the cosine of some phi. Phi is our angle that we got, plus or minus, really doesn't matter, times the inverse tangent of b divided by a. So this has to do with something that I was working on while going back from Italy to Germany in the car, because I was thinking about a router chick, and maybe you've seen my community post where I said that I was working 3 hours on this little math problem that escalated quite a bit. And 3 hours only because this problem right here drove me absolutely mad. After getting it done and after finding out what the issue was, I just felt like I never studied mathematics. I just thought, well, what the fuck? Why didn't I think about it earlier? This was the most complicated and most stupidly easy math problem at the same time that I ever encountered. And just because I'm a fucking retard. And you can try to follow along, and I'm going to explain what the problem is, or was, rather was. Now, I ended up with this part, okay, and what I wanted to find out is the angle. How can I basically solve an equation for the angle? And this equation right here, so this part was also equal to some kind of r. Really doesn't matter what you call it. So this was the equation that I ended up with and that I wanted to really solve for the angle phi. Now, on the angle phi, there were a few restrictions. My router chick, okay, it has to do with woodworking overall, so if you want to see a connection between woodworking and the like, and mathematics, go over to Flammy's Wood, subscribe there. So, thing is with the router chick, it was supposed to be only rotated by pi over 2, okay, from 0 degrees to pi over 2 degrees. So we are going to put a little restriction on it, namely phi is equal, not equal, but in the interval from 0 to pi over 2. Okay, so this was the first part. So we can rotate it like this, and also this b divided by a, okay, is always going to be greater than 1. Reason for that is that b is supposed to be greater than a. Once the video is out, you are going to understand better. Now those were a few restrictions, meaning also that b divided by a is strictly greater than 1. And simply enough, I thought I could easily solve this problem that we got right here just for phi, okay? Just like we do regularly on integration problems. For example, we substitute x being equal to the cosine of phi, and then I went ahead and took the inverse cosine if it's in the right interval from 0 to pi over 2, and then all will be good. So what I did most logically, and I didn't think about it any further, was I divided both sides by eta. This is not equal to 0 by definition, so we are going to get that r divided by eta is going to be equal to the cosine of phi minus the inverse tangent of b divided by a. And what I did, most logically, I just said, well, why not use the inverse cosine on both sides? Using the arcus cosine on both sides, we're going to get that the inverse cosine of r divided by eta is equal to phi minus the inverse tangent of b divided by a. And then I just added the inverse tangent on both sides, giving us overall that if we add it on both sides, that the inverse cosine of r divided by eta plus the inverse tangent of b divided by a is equal to the angle phi. And then I was checking with Wolfram alpha. I was already checking distances, and I knew that this formula that I got up here is definitely correct. This part is 100% correct, no errors in there. Then I was checking with Wolfram alpha, what about phi being equal to pi over 2. If I plug in phi being equal to pi over 2, everything worked out. The distance that I calculated was actually equal to what I got out here. Okay, this gave me the angle that I desired, pi over 2, and everything was well. But then I was trying around with other angles. For example, phi being equal to pi over 6. Then I suddenly noticed Wolfram alpha didn't agree with me. There was something weird. It spit out, after going through the calculations, putting the distance into here and the like, it spat out something like it should be 113 degrees. And I was like, no, it should be pi over 6, 30 degrees. And something wasn't adding up. And then I went through my calculations again and again for the router check again and again, and it just didn't stop, and it took me like 1.5 hours to figure out what actually was the problem, and it was something so fucking stupidly easy. I was checking steps in between, like dividing by eta at first, and this right here was still true. Then I noticed if I take the inverse cosine, it wasn't true anymore. Once I took the inverse cosine on both sides, I found out what the problem actually was, because the values didn't add up anymore. The equality just wasn't equal anymore. So here's where the problem lies, and I'm going to go through the whole process step by step. If we take a look at the cosine of some angle alpha, okay? If we get the cosine of alpha. Now, if our alpha is in a certain interval, then our cosine is what mathematicians call bijective. On a certain interval, if the cosine is bijective, we can actually take the inverse function, the inverse cosine, safely on both sides. If it's not bijective, we could run into possible contradictions. Now, what does it mean for a function to be bijective? What we are going to do is we are going to take a look at the cosine on a certain interval from 0 to pi over 2. If we take a look at the cosine from 0 to pi over 2, we are going to get this bump right here. Okay, this is just what the cosine looks like. And it goes from 0 to 1, meaning for the cosine of alpha, this is actually element of the interval from 0 to 1. Okay, this is like the y value, and also we are going to get that alpha is element from 0 to pi over 2. Now, when is a function bijective? A function is called to be bijective if it's injective and also surjective. Now, those are two new things I throw into the room, but what does it mean for a function to be injective? Injectivity means that if we take some f with respect to x equal to some f with respect to y, then this implies that x must be equal to y. This might seem kind of abstract at first, but it's actually pretty easy. What this just means is, if you take any two equal arguments in here, put them in here, for example, pi over 4 or the like, then it's going to give you the same x value out. Okay, so if we go here over here, so we are going to get, for example, for pi over 4, we are going to get square root of 2 over 2. Then if we take a look at the x values that we are going to get, they are going to be equal to the same thing. So if we take the cosine of pi over 4, then this does imply, if we get cosine of pi over 4 equal to pi over 4, this does imply that pi over 4 is equal to pi over 4. You might say, this is trivial, right? I mean, this does hold all the time, but it doesn't actually. If we take a look at the cosine curve further, then what you're going to notice is that this very point with the pi over 4, okay, can actually be gotten once again if we go over here. If we draw a horizontal line, we are going to get that it's going to intersect with our cosine curve once again over here, because we got a certain period in our cosine. So if we take a bigger interval into consideration for the cosine, it's not going to be injective anymore. But Obviously, on this interval from 0 to pi over 2, it's going to be injective, because for each and every y value that we got right here, we got exactly one x value which fits our description, our function. So, meaning our cosine is actually injective already. Now it also needs to be surjective. What does it mean for a function to be surjective? It means that for all y values, element of our, okay, in our case it's 0 to 1, there does exist some kind of x value or phi value, alpha value, whatsoever, is from 0 to pi over 2, such that the following holds, namely that the cosine of x is equal to y. What this means is, if we just take this interval into consideration, it really doesn't matter which y value we choose in here, there always does exist some kind of x value which is going to satisfy this equation. It could be different if we take, for example, the same interval from 0 to pi over 2, but this time we are going to take into consideration the y interval from -1 to 1. Now what happens here is, if we take a look at just this part, then down here we are going to get y values, okay? So taking a look, when does the cosine of alpha equal to -1, not y on this interval from 0 to pi over 2, this doesn't happen. There does not exist an x value in here which is going to satisfy cosine of alpha being equal to -1. Meaning from -1 to 1 as the y in interval, we wouldn't get a function which is surjective. But obviously, since we are going to consider it from 0 to 1, we are always going to find an x value for our corresponding y value. Okay, once again, meaning our cosine is actually bijective on this interval from 0 to pi over 2 and the y interval from 0 to 1. And if this is the case, if it's both injective and surjective, we are going to get that our cosine is going to be bijective, meaning we can safely take the inverse cosine on both sides. Now, I noticed that this isn't the case. I mean, I was checking for pi over 2. I was checking for pi over 2 in here, so phi being equal to pi over 2, and it did work out. But for example, pi over 6, it just didn't work out anymore. And here's why. Now, what we really need to take a look at is the argument in here of our cosine. What I just said is that our argument must be in the interval from 0 to pi over 2. Meaning our phi minus the inverse tangent of b divided by a must be bounded between 0 and pi over 2 in some way. So our phi minus the inverse tangent of b divided by a must be bounded, so it can be less or equal to this whole thing, between 0 and pi over 2. Now, is this always the case? Let us take a look at b divided by a, or the inverse tangent of b divided by a at first, because this is the point where it's going to fail overall. Now, b divided by a, as mentioned before, is going to be strictly greater than 1. Now, if we were to take the inverse tangent on this inequality, inverse tangent of b divided by a, then this is greater than the inverse tangent of 1. Now what is the inverse tangent of 1? If we take a look at the tangent curve, okay? It goes from negative pi over 2 to pi over 2. It looks like this, something, okay? Just like this. Now, what does it mean to have the inverse tangent of 1? This just means that we are looking for the tangent value of x where it's going to be equal to 1. When is this the case? This is going to be the case at pi over 4, because this is where the sine and cosine curves meet. Okay? Sine is equal to cosine, then sine over cosine, which is the tangent, is equal to 1. Now this right here is at pi over 4. If we get the inverse tangent of 1 is less than the inverse tangent of b divided by a. What this also means is that our inverse tangent of b divided by a is strictly greater than pi over 4 at all times. Meaning what we also get right here is that our phi minus the inverse tangent of b divided by a is also strictly greater than phi minus pi over 4 in each and every case. Now, if we get power over 2, for example. Power over 2, in here then we're going to get power over 2 minus power divided by 4 is going to give us power over 4 yet again. Power over 4 most certainly is in the interval from 0 to power over 2. Meaning, if we consider the interval from 0 to 1, 2, our cosine is going to be a bijective function, meaning we can take the inverse cosine on both sides, making this logic right here valid. But what happens if we consider, for example, very small angles of phi? And this is what I do for the router jig. Angles like 1 degree, 2 degree, 10 degrees, for example. 10 degrees. Let us take a look at 10 degrees. 10 degrees, phi, is equal to 10 degrees. Means that this right here is the same as dividing our par by 18. This is the same as par over 18. Now what happens if we plug par over 18 into here? Par over 18 minus par over 4. Par over 4 is definitely going to be greater than par over 18, obviously. Meaning what we get is a number which is strictly less than 0. If this right here is less than 0, then it's not going to lie in our interval from 0 to power over 2. And if this is the case, it's not going to be bijective on this bump that we considered right here. I mean, it can be bijective on this side right here, but then we would turn our whole calculations around. But what I wanted is my regular calculations to work. So this thing right here is not going to be, for small angles of phi, in our interval where cosine is going to be bijective. And if it's not bijective, I cannot just trivially take the inverse cosine on both sides. This is not something that is going to work out. And then I was thinking, what can I do to still make my calculations valid? What can I do to just turn this whole thing around and see if it's going to be bijective yet again? Well, it's so fucking stupidly easy. How can we turn this into something that is greater than 1? Greater than 0. I mean, fairly easy if we just multiply both sides by -1. But can you just multiply the argument in here by -1? Is that something that works out? Gladly you can. Cosine is an even function. Cosine of -x is the same as cosine of x. Meaning what we got right here is actually equal to eta times the cosine of the inverse tangent of b divided by a minus phi. And if we multiply the argument by -1 using the fact that cosine is an even function, we are going to get that for small values of phi, which we are going to consider for the router jig, this right here is going to be a bijective function yet again. Meaning the whole problem could have been solved instead of 1.5 hours of trying around once again by just turning around the argument in here, or just thinking back to my education at university and what it means for a function to be bijective. Meaning this whole thing right here is just going to change signs around, and overall we are going to get a negative sign right here and a positive sign here being equal to phi. And this was the whole problem. There was nothing more to it. I was just being stupid as fuck. And I hope you could follow what I was talking about here. The lesson that you should take away from this video is that you should definitely study mathematics. And once you study mathematics, you shall not forget about the basics that you learned in the first semester and used up until the last semester of the masters. Yeah, this is basically the lesson you should take away from this stupidly long fucking video. Yeah, and this basically just finishes what I wanted to say about this problem. I just wanted to present it to you guys because I fail all the time at mathematics. I do dumb goofs all the time and I fuck it up regularly, even in my videos from time to time, as you might have noticed before. And no one is perfect, and you can always fail at your task, and you should always think back to the total basics. And well, I got used to taking the inverse cosine all the time, or the inverse trigonometric functions, just because for the nice integrals I post here on this channel, it does work like a charm all the time. But there are situations where it doesn't work out, and you should always keep this in mind. Always double check your answers with Wolfram Alpha. Okay? No, let Wolfram Alpha do the whole thing. This is what you should take away from this video. Never calculate something on your own. Always use Wolfram Alpha and let it do the mathematics. And I hope you guys did enjoy this video, even though this was just straight up talking and basically completely improvised and I didn't really know what to say. I just want to present this problem to you. Other than that, please make sure to definitely check out Flammy's wood. It would mean a lot. Yes, I have wood lying around next to my chalkboard. It would mean a lot to me if you could check it out and support the other channel this way. And yeah, don't forget to check out STEM Merge EU too. And up until the next video, I wish you guys a flammable day and please stay safe. Ciao.